In this video, I'm going to talk about how you're going to find the LU. So L stands for lower triangular matrix and U stands for upper triangular matrix given a certain matrix A. So let's start with a random matrix, as we always do. Our random matrix is going to be -2, 4, 8, -4, 18, 16, -6 to -20, and this is going to be our matrix A. So the LU, lower triangular matrix and upper triangular matrix, is a pretty simple method, which is generally you're generally gonna find it in your numerical method or in your linear algebra class, but generally in your numerical method or mathematical method class. So the way to find the LU matrix is that you're actually only going to find the upper triangular matrix, and then the lower triangular matrix is going to be given by the multiplicators used to find U, so the upper triangular matrix. So let's find the upper triangular matrix first. So our U upper triangular matrix is gonna be, well, and just write down the matrix and do all the steps. So -2, 4, 8, -4, 18, 16, -6 to -20. Okay, so I'm gonna do the second minus 2 times the first one. You know, as you always do when you do the reduction. Okay, so the first one is gonna stay the same, 2, 4, 8. The second minus 2 times the first one, so I'm gonna get 0, 10, 0, and I'm gonna get the third one is gonna stay the same, so -6 to -20. Okay, and I'm gonna highlight this one here with blue. I like blue. There we go. Because this is going to be our multiplicator. This is important. We generally don't keep track of this in linear algebra, but this time, since we've got to find the lower triangular matrix, we're going to keep track of this, which is our multiplicator. All right, so let's keep going on with the reduction. So I'm going to do the third one minus 3 times the first one. Okay, and again, I'm going to keep track of these 3 here because it's important. It's going to be our multiplicator. So I'm just going to write back the first and the second one. So -4, 4, -2, 4, 8, 0, 10, 0, and I'm gonna get the third one, so this one, minus 3 times the first one, so gonna get a 0, -10, and -44. Okay, we are almost done. I think I just have to do one more step, and this time I'm gonna do well, I'm gonna do the third one minus -1 times the second one. I know it may sound silly because we generally, multiply and then do the other thing, but in this method we're gonna keep track of the multiplicator, so you can just multiply and multiply that, but I think this way is the a nice way to do it. So we're gonna keep track of this -1. You can just multiply and then do the minus later as we always do, but this time I'm gonna do both of them at once as I did it for in these other two occasions. So the third one minus -1 time the second one. So I'm just gonna write the first two back. So -2 for 8, 0, 10, 0, and then just gonna do the third one minus -1 times the second one. So 0, 0, and -44. Okay. So this is gonna be our matrix, and it is the main diagonal of our newly found matrix. Now, so this is upper triangular matrix, the one we just found, this one here. Okay, so right now we don't have to calculate lower triangular matrix. So our target right here was to get the upper triangular matrix, so to get the 0, 0, 0 over here and get our pivot over here and values over here. And we did it. We did it with row reduction and a few, steps. So right now we don't have to do the same thing again for the lower triangular matrix. What we can just, the reason why we kept track of the multiplicators is that we can just use the multiplicators to find the lower triangular matrix. So our lower triangular matrix is going to be given by the identity matrix. So 1, 0, 0, 1, 0, 1. Okay, here. And the lower part is going to be given by what? Well, our multiplicators. So 2, 3, and -1, respectively. So 2, 3, and -1. And as you can see, these are our multiplicators. This is the identity matrix with the main diagonal, and this as a whole is our lower triangular matrix. So it's not that hard. You can do it by yourself. So well, let's do one more example. Okay, let's suppose that we have we want to solve a linear system of equation, and we want to use the LU method. So because I just show you how to find LU, but from a matrix, but I didn't actually tell you what this is used for. This is actually used for mainly for solving system of linear equations. So let's suppose we have our new matrix, which is this matrix here: 7, 8, 9, 4, 5, 6, and 0, 2, 3, and which is our matrix A, and C is 24, 15, and 5, which will give us well, this our vectors x 0. It's going to give us 7x plus 8y plus 9z equal 24, 4x plus 5y plus 6z equal 15, and then just 2y plus 3z equal 5. Right, a linear system of equation. So let's do it again. So we want to find the upper triangular matrix. So upper triangular matrix. Okay, so our U, let's just write the matrix of the coefficients down again. So 7, 8, 9, 4, 5, 6, and 0, 2, 3. Okay, so again, we're going to do the exact same thing again. We want to do the row reduction in order to have upper triangular matrix, and we're going to keep track of the multiplicators and use them to find the lower triangular matrix. So I'm just going to do the second one minus 4/7 times the first one. Okay. This is going to be our first multiplicator. So, okay. So this one is going to stay the same. And this one is going to become 0, 3/7, 6/7, and then 0, 2, and 3. And then I'm going to do the third one, minus 14/3 times the second one. It's going to be our next multiplicator. So I'm basically going to get 7, 8, 9, 0, 3/7, 6/7. I just want to get a 0 here, so 0, 0, -1. Okay. It's going to be our diagonal, main diagonal, and as you can see, we've got 0, 0, 0, so this is our upper triangular matrix. So we are kind of happy here. And thanks to the multiplicators, we're basically gonna find the lower triangular matrix. But you may think something is basically gonna click in your mind here, because you know you will be saying, hold on a second, you said that you wanted a upper triangular matrix, right? Yes, but you already had a 0 here, therefore you had a 0 here, and therefore you had a 0 here. Yes. And then you did the reduction as well, but only 2 of them, because you just wanted to have a 0 here and a 0 here, so you got a 0 here and a 0 here. Therefore you got an upper triangular matrix. Yes. And therefore you ask, okay, then what am I going to insert, to write into the lower triangular matrix, as I only have 2 multiplicators? Well, the answer is simple: 0, because you didn't do anything, so the multiplicator is 0. It was already going to be 0. So the lower triangular, this is the upper triangular matrix. Your lower triangular matrix is going to be the identity matrix, as I said. So 1, 0, 0, 1, 0, 1. And I'm going to use the multiplicator, so 4/7, which is this one, and 14/3, which is this one. This one here is going to be a 0, because we didn't do anything. We already got a 0 here, so we didn't have to do anything. So those are our multiplicators. I'm gonna circle this one as well, because this technically a multiplicator is a 0 multiplicator. And this one is going to be our main diagonal given by the identity matrix. And there we go. So this is our lower triangular matrix. There we go. So this is how you do the LU. Do you use the LU method? So right now you should solve the system of equation, to be fair. So you should do more things, and I'm going to show you how to do this. I don't have another page. Yeah, I can do this in another page. Okay, I'm gonna do this in another page. So the idea here is that we basically had A times a vector, okay, which is our x0 equals C. Okay, so this was our system of linear equation. And we know that LU equal A. Okay, therefore, we know that LU X is equal to C, because we know that, A cos A X was equal to C, was our system of linear equation that we started with. So right now we're gonna use, we're basically gonna put L y equals C. So we're basically gonna do L and a newly created vector, which is y. So I j k. Our vector x was x y z. So this one was supposed to be x y z. You know, x just is as I write it, x y z. You know, so this is gonna be our newly created vector. So I j k, and then I'm gonna put L y, so the lower triangular matrix y I j k equal to C. I'm gonna do it here. Okay, so we're basically gonna say that y, our new values, our new values are gonna be the lower triangular matrix that we just found. So 1 0 0, 4 over 7, 1 0, 0 14 over 3 1. This was the identity matrix with multiplicators, so the lower triangular matrix that we just found. So times I j k, we are working in R3, so in the three-dimensional space, it's going to be equal to 24 15 5, which was our C that we had at the very beginning. So this one is basically going to turn into this system of equation. 1 times I plus 0 times j plus 0 times k equal 24. And then we're going to have 4 over 7 times I plus 1 times j plus 0 times k equal 15. And I'm gonna have 0 times I plus 14 over 3 times j plus 1 times k equal 5. Okay. Therefore, we're gonna have I equal to 24. 4 over 7 I plus j equal to 15, and 14 over 3j plus k equal to 5. And again, we keep going on. And we have I equal to 24. 4 over 7 times 24 plus j equal to 15. 14 over 3 j plus k equal to 5. Crappy bracket. Okay, and then we keep going on and on and on. So we're gonna have I equal to 24, 96 over 7 plus j equal 15, and 14 over 3j plus k equal 5. And then we're gonna have I equal 24, and j equal 15 minus 96 over 7, 14 over 3j plus k equal 5. And then we're gonna have I equal to 24, j equal to 105 minus 96 over 7, and then we're gonna have 14 over 3j plus k equal to 5. Okay, and we keep going on, and we have I equal to 24, j equal to 9 over 7, and 14 over 3 times 9 over 7 plus k equal to 5. And keep going on, and we have I, which is equal to 24, j equal to 9 over 7, and 6 plus k equal to 5. And we keep going on, we're getting closer. I equal to 24, j equal to 9 over 7, and k, which is equal to 5 minus 6. And last but not least, we have I equal to 24, j equal to 9 over 7, and k equal to -1. Okay, so we found our newly created vector I, j, and k, so those values. So our new vector y with the component I, j, and k is basically given by 24, 9 over 7, and -1. But hey, this is not the end of this is not our solution, it's our temporary vector. So we're gonna solve ux equal y. So basically we're gonna say, okay, we basically found these y, that is I, j, and k. Now we're gonna get our u upper triangular matrix that we had before, times the variables that we had with the x vector, so x, y, z in a three-dimensional space. We're gonna put those equal to the numbers we have just found, I, j, and k. So let's just do that. Our upper triangular matrix was this one here. So let's write it. Our upper triangular matrix was 7, 8, 9, 0, 3 over 7, 6 over 7, 0, 0, -1. So this is our upper triangular matrix. And we're just gonna find our solution. So times x, y, z, our first vector, x, and which is gonna be equal to the values that we just found. So 24, 9 over 7, and -1. Okay, so this is gonna give us this nice system: 7x plus 8y plus 9z equal 24, 3 over 7y plus 6 over 7x equal 9 over 7, and then we have negative z equal to -1. Therefore, we have 7x plus 8y plus 9z equal to 24. 3 over 7 y plus 6 over 7z equal to 9 over 7, and then z equal to 1, because now it's z. And then we're just gonna go on. Okay, so let's go on. We're gonna have 7x plus 8y plus 9 times 1. We just substituted the x equal to 24. So 3 over 7y plus 6 over 7 times 1 equal to 9 over 7, and z equal to 1. And we're going to go on, and we're going to have 7x plus 8y plus 9, and 9 was times 1, equal to 24, and 3 over 7y plus 6 over 7 equal 9 over 7, and z equal to 1, that we had already found and we used. So we're gonna go on. We're gonna have 7x plus 8y equal to 24 minus 9, 3 over 7, y equal to 9 over 7 minus 6 over 7, and z is still equal to 1. And it's going to stay like that. Okay, and let's go on again. Okay, so I'm gonna get 7x equal to 15 minus 8y. Then I'm gonna get 3 over 7 y equal to 9 minus 6 over 7. And z is still equal to 1. And I'm gonna get 7x equal to 15 minus 8y, 3 over 7y is equal to 3 over 7, and z is still equal to 1. We're just gonna go on again.